The oil-drop apparatus contained an electric field which was essentially formed through a pair of parallel metal plates. Millikan's oil-drop experiment utilized the strength of the application from the electric field, the density of the oil drops, and the strength of the unknown gravitational force to determine the charge of the balanced oil drops. The oil drops that did not rise or fall were a result of the electric field balancing with or overcoming the strength of the gravitational force on the droplets. The fundamental charge was thus created when Millikan discovered that the charges are all multiples of a specific number, the newfound charge of an electron. By balancing downward gravitational force with upward drag and electric forces, they were able to hang tiny charged droplets of oil between two metal electrodes. Because the density of the oil was known, Millikan and Fletcher were able to calculate the masses of the drop based on their observed radius, since from the radius they could calculate the volume and thus the mass. Using the known electric field and gravitational values as a starting point, Millikan and Fletcher have found that an extremely low vapor pressure oil, for example an oil designed for use in a vacuum device, was best used. Under the heat of the light source, ordinary oil would evaporate and make the weight of the oil drop change during this experiment. A uniform electric field was created between them by applying a potential difference to a parallel pair of horizontal metal plates. The plates were held apart by a ring of insulating material. 4 holes were slashed into the ring, 3 for a bright light and 1 for microscope viewing. A fine nebula of oil droplets has been sprayed over the plates into a chamber. The oil droplets were loaded by the nozzle when they were sprayed electrically. Otherwise, the charge may be caused by ionizing sources of radiation, such as an X-ray tube.